if A is to B is equal to C is to D, prove that each given ratio A upon B and C upon D is equal to this much, and this much. Three separate questions here. So first take the first what they want. They want to prove that there's a question is prove A upon B is equal to this much, C upon D is also equal to this much, right? Each ratio should be equal to this one, and each ratio is equal to this one, each ratio is equal to this one as well. So let's take the first question in it. The first question says okay, I'll take here use the K method, easiest one. So A upon B is equal to C upon D. This is they have given you. So we'll say let it be equal to some constant K. So what does it mean? It means A upon B is equal to K, and it also means C upon D is equal to K. So when A upon B is equal to K, so does it not mean A is equal to BK? Important one, keep it. This is also mean here C is equal to DK. Remember, this is what we will be using it. Let's take the first question. So what is 3A? Substituted 3. What is A? A is BK. At the place of A, I'm writing BK here minus 5. What is C? DK here. So I'm writing here at the place of C, DK. You yourself will understand why we are doing it. So it will give you what? Here 3B minus 5D. After that, I'm writing here. Now we can take what is common in it. I think is K is common. So I can take K common. What is left? 3B minus 5D. So here in denominator 3B minus 5D. Now you realize why we had done that. So that yes, we can get these two cancel is the same thing, right? Numerator and denominator. You're left with K. And what was K? K was equal to A upon B. And what was K? Also C upon D. So is this one that we have got finally A upon B, K which is equal to A upon B and C upon D. So hence this is proved here. We'll do the second part of it. Second part is 2A square plus 9C square root of 2A square plus 9C square, okay, and the second part was 2A square plus 9C square upon 2B square plus 9D square. B square plus 9D square. Remember, this root is for all this entire thing, okay? This is the entire thing together. Now, coming to, let's solve this part. So I'll put the value here. What was A? We had taken A as BK. So right here A as BK. But it was BK is A square, so it will be BK square plus 9. C was what? DK. So right here DK, but it is DK square. Why? Because it was K, sorry, it was because DC square. So this will be square upon everything at the bottom will remain the same, 2B square plus 9D square, because we don't have anything for that. After that we'll write here 2b square k square plus 9d square k square upon 2b square plus 9d square, everything under root. So that will give you k square taken common in it, and what is left? 2b square plus 9d square upon 2b square plus 9d square, and everything under the root. This will get cancelled, so you are left with k square under root. So what is k square under root? That is equal to k. And what was k equal to? A upon b. It was also equal to c upon d. So hence it is proved here. Third question is here. Third question that we have is, just take the third question from here and put it here. Wondering why I made it so small, because it's not 100%, so that's the reason it happens. Okay, the third question that we have to do it quickly. 5 a to the power 3 means, what was a? A was bk, so right here bk the whole power 3 minus 13c was dk. So dk the whole power 3, because the power is 3, the whole thing upon 5 b to the power cube minus 13 d to the power 3. So I will write the same thing here as well. I can take k cube common. We know it is cube for both of those. Okay, if you do not understand, so I'm writing it for students who don't understand. 5 b cube k cube minus 13 d cube and k cube upon 5 b cube minus 13 d cube. So further can write k cube is common. I forgot to write the whole power, 1 by 3. This also has the whole power, 1 by 3. Basically is a cube root, k cube, and what is left? I've taken the k cube as a common, so you're left with 5 b cube minus 13 d cube, the whole thing upon 5 b cube minus 13 d cube, and this whole thing under root, not under root, the whole power is 1 upon 3. So I can write it 1 upon 3. So this will give you can see there the same thing here and here will get cancelled. So you're left with k to the power 3, the whole power 1 by 3, and we know that k to the power 3, the whole power 3 means 1 upon 3 will get cancelled, and you are left with k, which was equal to a upon b that we had assumed it, and also c upon d, and then we can say hence it is proved here.